There's a myth that we need to shatter that AI is always right. And here's the trap: students believe that because the AI sounds confident, it must be correct. So they copy the answer, they skip the thinking, and just turn it in. That's not learning, that's outsourcing cognition. But what if we change the power dynamic? What if we train students to interrogate the AI, not rely on it blindly? In this episode, we're going to walk you through how to build math assignments where students spot, explain, and fix AI generated errors, turning every mistake into a lesson in real mathematical reasoning. Let's dive in. So, step one: make AI a thinking partner and not an oracle. Start by assigning a problem and asking students to solve it themselves. Then prompt the AI to solve it too. And then have them compare both solutions. But here's the twist: ask students which one is better, why, do they match, what assumptions did the AI make. This creates a tension between confidence and accuracy and teaches students to think like mathematical detectives. Step two: give students flawed AI outputs on purpose. Use your teacher account to prompt AI to solve a problem incorrectly. You can do things like mislabel a variable, apply the wrong formula, skip a key step in reasoning, then present the AI solution and ask, what's wrong here? Why would a student believe this is correct? How would you fix it? This moves the student from passive consumer to critical evaluator. Step three: require full error breakdowns and not just corrections. Ask for things like a labeled copy of the error, a written explanation of why it's wrong, a corrected version with full justification, a short reflection asking, what misconception does this reveal? Now we're assessing conceptual understanding, not just procedures. Step four: connect AI errors to common student errors. So you can pose questions like, is the kind of mistake you or your classmate would make? Is this the kind of mistake that you or your classmate would make? Then use the AI response to spark a discussion. Why do people misuse this formula? What happens if you forget to distribute? Why is this assumption mathematically invalid? This now creates shared language around reasoning traps, and it reinforces the value of conceptual clarity. Step five: use error analysis as an entry point to complex concepts. Don't just do this with basic algebra. You can try this with trigonometric identities that's misapplied. You can use it for incorrect assumptions in geometry proofs, flawed interpretations of statistical graphs. So, for example, AI claims that the sine of 60 degrees is 0.86 because it used degrees, but then apply a radian based formula and explain the mistake. That's not just math, it's mathematical literacy. Step six: you can have students create their own flawed AI outputs. An assignment idea would be use AI to generate a solution. Intentionally modify it to include a small but meaningful error, give it to a peer, and find it and fix it. Now, students are internalizing misconceptions so deeply that they can design around them. And now that's high level thinking. Step seven: you can integrate error analysis into your routine and make it a habit. You can create a weekly bot blunder or AI slip up assignment. You can post a flawed solution, ask students to write what the AI got wrong and why. You can award points for depth, not speed. This builds muscle memory around mathematical vigilance. Step eight: grade the reasoning, not the result. Your scoring guides can be 30% that goes towards identification and clarity of error. 30% can go to conceptual explanation of a mistake. 20% can go to a revised or corrected solution. And 20% can go to metacognitive reflection. What did you learn from this? This rewards mathematical maturity and not just getting it right the first time. Might be fast, but it's not always accurate and not always deep. And if we let students believe that fast equals correct, we are giving away their greatest asset, which is their judgment. Error analysis flips the script. It tells students, you are the mathematician, you are the validator, You are the one who must decide what's true. Because if we want kids to build real understanding, we have to let them wrestle with what's not working and why. And when they do that, AI is no longer a threat. It's a tool for cognitive confrontation. And in that tension, that's where the learning lives. Stay tuned for more episodes.